In today's video, I am going to discuss matrix. I will give a very small yet succinct idea on the linear transformation, and then I will go to the idea of matrix. Now, you all know, if you have a little bit of high school mathematics or a little bit of college mathematics, then you know that a matrix is a squared array of number or a rectangular array of number. For example, if you have these 3 rows and 3 columns, and at the intersection of all the rows and columns there are numbers. So it can be like this. For example, this is a matrix . This is a matrix which has got 3 rows and 3 columns. Likewise, a 2 by 2 matrix will be like this. It has got 2 rows and 2 columns. But if you go to the geometry of these notation matrix, then you will find that the row and the column, the existence of row and the column in a matrix is little bit obvious. Let us show you the geometry part. In a 2-dimensional flat plane, this is x-axis and this is y-axis. You consider this point. You consider this point. This is 1, 0, and you consider another point on the y-axis, call this 0, 1. These points are situated at unit length from the origin. We call these following vectors as I vectors, and this is j vector. Now, if these 2 axes are rotated in 90 degree, then what happens? You find 1, 0 lands here, so it becomes 0, 1, and this point 0, 1 comes over here, it becomes minus 1, 0. So the point 0, 1 goes to minus 1, 0. You just write these transform vectors in 2 columns, 0, 1 and minus 1, 0. This is a matrix obtained by rotating the axis. So, if you rotate the axis, all the points on this page will rotate 90 degree, but you do not have to think about all those points. You just concentrate the point 1, 0 or the vector I, where does it go, and the point 0, 1, where does it go. You just concentrate on that two points, and this will give you the matrix in 2 dimension. Likewise, in 3 dimension, if you consider these are the matrix, then this is the column where the I vector in 3 dimension, that means here I would be like this, 1, 0, 0. So 1, 0, 0 become 1, 4, 7, and j, which will be in 2 dimension 0, 1, 0, this will go to here, and since it is a 3-dimensional space, so there is another vector 0, 0, 1, this will go to here. So, in terms of physics, this will be called the rotation matrix. We can consider another matrix likewise. Say, for example, not rotation but a shear takes place. For example, in a shear, this I remains I, so this point will not move, but this point 0, 1 will go to here, so it will go to here. So it becomes 1, 1. You just consider these two vectors, where does it go? So the corresponding shear matrix will be I remains at I, so this is 1 0, and j goes to 1 1. So this is another 2 by 2 matrix. So it transforms this axis in a orientation so that x-axis remains x-axis by y, but y-axis is rotated counterclockwise direction, making angle 45 degree with x-axis. In this case, all the points have rotated 90 degree, and this has yielded this rotation matrix. So whenever you find any matrix, you should understand there is a inherent transformation that has taken place in the space, whether it is a two-dimensional flat plate or a three-dimensional space. These can be extended even to n-dimensional. So we can generally consider a matrix, if we consider these as a matrix in 4 dimension perhaps, but we have taken it in a very arbitrary way. This is a 4 by 4 matrix having 4 rows and 4 columns. It's called square matrix. In this case, the vector I there in 4 dimension has gone to this place. These are not real spaces because the real spaces is only up to 3 dimension. So this can be extended to n-dimensional space, and we can yield n row n vector square matrix. So the idea of matrix and the idea of linear transformation are closely knit to each other.